So in the first problem we have to find the sum of the following. We have 3 subdivisions, we will do one by one. In the first subdivision we are given with the sequence 3, 7, 11, it is up to 40 terms. Therefore the value of n, it is 40. Value of A is nothing but the first term in the sequence, which is 3. Similarly we can find out the value of D, which is T2 minus T1. T2 is the second term, 7, minus T1 is the first term, 3. 7 minus 3, it is 4. Therefore D is equals to 4. Now we have to use the formula of Sn to find out the sum of the following. We know only the first term, we don't know the last term in the sequence. Therefore we can use the formula Sn is equals to n by 2 into 2a plus n minus 1 into D. So S40 is equals to 40 by 2, 2 into A value is 3 plus N value is 40, therefore 40 minus 1 into D value, it is 4. Simplifying this will give me 40 by 2, it is 20, 2 3s are 6 plus 39 into 4. So 20 into 6 plus 39 into 4, it is 36, 3, 12, 15. So 20 into 156 plus 6, it is 162. Therefore 162 into 2, it is 4, 12, 3. So 3240 is the sum of the following sequence. In the second subdivision we have to find the sequence up to 27 terms. Therefore value of n, it is 27. Value of A is nothing but the first term in the sequence, which is 102. Similarly we can find out the value of D by using T2 minus T1 or T3 minus T2. We will use T2, T3 minus T2, which is 92 minus 97. Therefore D equals to minus 5. So let us use the formula of Sn as n by 2 into 2a plus n minus 1 into D. N value, it is 27. Therefore S27 is equals to 27 by 2. 2 into A value, it is 102 plus n is 27 minus 1 into D value is minus 5. 27 by 2 into 204 plus 26 into minus 5. Therefore 27 by 2 into 204 plus into minus will become minus 26 into 5, it is 33, 10, 13. So 204 minus 130 is 27 by 2 into 74. Therefore cancelling this, 37. So 27 into 37, it is 49, 4, 14 plus 4, 18, 21, 2, 6, 8. Sum of first 27 terms for the above sequence is 999. So we have to find the sum of the following for the given series. Let us find using the formula Sn is equals to n by 2 a plus l, because we are given with the first term and the last term for this series. So we can use this formula, whereas a value is 6 and L value is 97. We can find out the value of D by using T2 minus T1. T2 value, it is 13 minus T1 value, it is 6. Therefore D equals to 7. But we are not given with the value of n. We will find out first the value of n, then we can simplify in this. So for finding the value of n, we can use the formula L minus A by D plus 1. L value is 97 minus 6 by D value is 7 plus 1. 97 minus 6, it is 91 by 7 plus 1. 91 by 7, it is 13 plus 1, which is equals to 14. Therefore n value we got as 14. Now we will substitute the values in Sn. So Sn is n value is 14. Therefore S14 is equals to 14 by 2. A value it is 6 and L value it is 97. Therefore, 6 plus 97, 14 by 2 into 103. Therefore, 7 into 103, which will give me 7 3s are 21 into 7 into 1 7. Therefore, sum of 14 terms for the given series is 721. So, in the second problem we are asked to find how many consecutive odd integers beginning with 5 will sum to 480. That is, sum to 480. Sn value is given and we have to find and odd integers beginning with 5. We have to find out the value of n. We are given with Sn is equals to 480. That is, sum of n terms is 480. What is the sum of numbers represent is sum of odd integers beginning with 5. Sum of odd integers beginning with 5 will give me the sequence 5, 7, 9, etc. It goes on. From this we can write the value of A, which is 5 since it is a first term, and the value of D is T2 minus T1, that is 7 minus 5, it is 2. So now we know the value of Sn as well. We can find out the value of n using the formula Sn is equals to n by 2 into 2a plus n minus 1 into d. So Sn value it is given as 480, which is equals to n by 2. 2 into a value is 5 plus n minus 1 into d value it is 2. Let us simplify this. 480, if it goes to the other side, it will become 480 into 2, which is equals to n into 10 plus 2n minus 2. Therefore, 480 into 2 it is 960, which is equals to n into 10 minus 2 it is 8 plus 2n. Now what will we do is we will take 2 common from these two terms. It will become 960 equals to 2. If I take it outside, 2 into n, 4 plus n. 2 I will take it to the other side, it will come to the denominator. Therefore, it is 960 by 2, which is equals to n into 4 plus n. If we cancel this, we will get 480. Next is 480, which is equals to n into 4 plus n. We will simplify this. 480 equals to 4n plus n squared. We will write it in order, quadratic equation order, n squared plus 4n. 480, if it goes to the other side, it will become minus 480 equals to 0. Now we will find out the roots of the equation for n. So if we multiply, we should get it as minus 480. Adding it, we have to get the value as 4. We have to choose the roots in such a way. We will choose 24 into minus 20, because 24 into minus 20 it is minus 480. 24 minus 20 it is 4. So let us use it here. Therefore we can write this as n plus 24, n minus 20, which is equals to 0. Simplifying this, we will get n plus 24 equals to 0 and n minus 20 equals to 0. N is equals to minus 24 and n is equals to 20. The value of n couldn't be negative, therefore n is equals to 20. Thus we have found out the value of n as 20. In the third problem, we have to find the sum of first 28 terms. That is, we have to find S28. For this, we are given with whose nth term is 4n minus 3. That is, Tn is equals to 4n minus 3 is given. Let us consider this as an equation 1. Using this, we can find out the first term, second term and the 28th term. Then we will use the formula of Sn and we will find out the value of S28. First, what will we do is, if I substitute the value of n as 1, we will get the first term in the sequence, which is T1. Therefore, T1 is equals to 4 into 1 minus 3, 4 minus 3, 1. So first term in the sequence is 1. Next T2 equals to 4 into 2 minus 3. 4 2s are 8 minus 3, it is 5. Second term in the sequence it is 5, and the 28th term in the sequence can be found out by using the value of n as 28. 4 into 28 minus 3, which is 8 4s are 32, 3 balance, 4 2s are 8, 112 minus 3, it is 109. Therefore 109. We can find the value of D using the AP, that is D is equals to T2 minus T1, which is 5 minus 1, it is 4. So D equals to 4. So let us use the formula of Sn as n by 2 into A plus L. We know the value of n as 28. Therefore S28 equals to 28 by 2. A value is 1 plus L value is 109. So 28 by 2, it is 14 into 110. Therefore 14 into 11, 14, it is 154. So 1540. S28, that is sum of first 28 terms is 1540. In the fourth problem, we are given with sum of first n terms of a certain series is given, that is Sn value is given as 2n squared minus 3n. What we have to do is, this series is an AP. We have to show that the series is an AP. We know the value of Sn only. First, to find the series of an AP, we need the value of Tn. Why we need the value of Tn is, if we know the value of Tn, we can find out first term, second term and the last term, and we can conclude that whether it is an AP or not. So we need to find the Tn for that. For finding the Tn, what we have to do is, we can use the formula sum of n terms minus sum of n minus 1 terms, which is nothing but it will give the value of a Tn. So Sn, it is given as 2n squared minus 3n. Similarly, Sn minus 1, in the sense we have to substitute the value of n as n minus 1. Therefore, what will we get? Minus 2 into n minus 1 squared. Here we have minus and we have minus here as well. It will become plus 3 into n minus 1. Therefore, what will we get? Tn is equals to 2n squared minus 3n minus 2 into this, we will expand using the formula a minus b whole square, which is a square minus 2ab plus b square. Value of a here it is n and the value of b is 1. Therefore n square minus 2 into a into b. Therefore 2n plus b square is 1 square plus 3n minus 3. So we will simplify this. 2n squared minus 3n minus 2 into n squared minus into minus plus 4n minus into this is minus 2 plus 3n minus 3. So plus 2n squared and minus 2n squared will get cancelled. Minus 3n and plus 3n will get cancelled. The remaining term is Tn is equals to 4n minus 2 minus 3, it is minus 5. So thus we got the value of Tn. Using this we can find out whether the series is an AP or not. How to do that? We have found the Tn. So from this we can find out the first term of an AP if we substitute the value of n as 1. Therefore T1 is equals to 4 into 1 minus 5. 4 minus 5, it is minus 1. I will write the sequence here, minus 1. Next is T2 is 4 into 2 minus 5. 4 2s are 8 minus 5, it is 3. Therefore 3. Next, if I substitute the value of n as 3, Tn 3 is equals to 4 into 3 minus 5, which is 12 minus 5, it is 7. Next, we will substitute the value of n as 4 to get the fourth term. 4 into 4 minus 5, 4 4s are 16 minus 5, it is 11. 11. So we'll check whether we got the series is an AP or not. Let us check by doing T2 minus T1. D equals to T2 minus T1 will give us 3 minus, here we have 1 minus, it will become plus 4. D value is 4. We should check whether if we do T3 minus T2, whether it gives the same value 4. So D equals to T3 minus T2. T3 value is 7 minus T2 value is 3. So 4. Yes, it gives the same number 4. Similarly, if we subtract T4 minus T3, that is 11 minus 7, it will also give us the value 4. So this series we got is an AP. Thus we have shown the given series is an AP. In the fifth problem, we are given with 104th term and 4th term of an AP are 125 and 0, which is meant as 104th term is 125 and 4th term is 0. We have to find the sum of first 35 terms, which means we have to find the value of S35. So with the given hints, we will find out the required values A and D. So first it is given as 104th term. 104th term is expressed as T104, which is given as 125. Now what we are going to do on the left hand side is we are going to use the formula of Tn as A plus n minus 1 into D. So n value here it is 104. Therefore A plus 104 minus 1 into D equals to 125. A plus 103 into D equals to 125. This we will consider it as equation 1. Next what will we do is we will take the second hint, that is 4th term is 0. 4th term we represent it as T4 is equals to 0. Now similarly we will use the formula of Tn. A plus n value is 4 minus 1 into D, which is equals to 0. Therefore A plus 3D is equals to 0. Let us consider this as a second equation. Now equating these two equations using the linear equations, we can find out the values of A and D. Then we can find out S35. So A plus 103, D equals to 125. A plus 3D equals to 0. Let us change the signs. Minus, 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 plus A minus A will get cancelled. 103 minus 3 will give me 100D, which is equals to 125. Therefore D equals to 125 divided by 100. In 25 tables it will go 5 by 4. Therefore D equals to 5 by 4. Thus we got the value of D. Simplifying the D value in any one of these two equations, we can find out the value of A simply. I will consider the second equation to substitute the value of D and find the value of A. A plus 3, D equals to 0. A plus 3 into D value is 5 by 4, which is equals to 0. 5 3s are 15 by 4. If I take this 15 by 4 to the other side, it will become minus 15 by 4. Therefore, A is equals to minus 15 by 4. So, we got the values of A and D. Now, we can use the formula and find out the value of S35. S10 is equals to n by 2 into 2A plus n minus 1 into D. Value of n is 35, therefore S35 is equals to 35 by 2 into A value, we got it as minus 15 by 4 plus 35 minus 1 into D value, we got it as 5 by 4. So S35 equals to 35 by 2. This if we get cancel, we will get minus 15 by 2 plus 34 into 5 by 4. In two tables, we will get this 17 times, this is 2 times. So, 35 by 2 into both the denominators as 2. So, let us simplify the numerators directly. Minus 15 plus 17. Minus 15 plus 17 into 5. So, what will we do is 35 by 2 into minus 15 plus 17 into 5 by 2. So therefore 17 into 5 it is 35, 3, 85. So 85 by 2. So 35 by 2 into 85 minus 15, it will give me 70 by 2, 35. Therefore 35 into 35 it is 25, 2, 15, 17, 15, 1, 9, 10, 5, 2, 2, 1. So 1125 divided by 2, 612.5. Yes, 35. The sum of first 35 terms is 612.5.